The need to have the pipeline buried the whole distance from the connection to the water treatment plant and on into Payson is for several reasons. Security, of course, being the biggest one. Lessen the impact on the environment is a very important aspect. And the high pressures that are encountered in some areas of the pipeline, up to 470 pounds per square inch of pressure, you feel a lot better that pipe being in the ground with the earth holding it steady than up on a trestle with physical restraints holding it down. So there's many reasons that it needs to be underground.
There's no freezing issues, there's no vandalism issues. It's out of sight, out of mind, and we should never have to deal with it. So it will all be buried even when we cross the East Verde. We end up crossing the East Verde 3 times. It will be down below grade and then encased in concrete.
When you construct across the river, there are many times of the year when the river is at low flow, or we can make it be at low flow by asking the Salt River Project to discontinue temporarily pumping operations that would create a high flow in the reservoir by adding water to the East Verde River from C.C. Cragen Reservoir.
The river crossings were challenging. So when I talk about river crossings, that's crossing the East Verde River while the river's still flowing.
They're not only a problem because there's water in that riparian area, but 2, there's protected species of birds and fish and different animals that need to be taken care of.
While the project was being constructed, narrow-headed garter snake was listed as an endangered species.
The narrow-headed garter snake, this species was listed in 2014, and the factors that influenced that species to be listed included high severity wildfire, the presence of harmful non-native species like crayfish, bullfrogs, and spiny rayed fish like bluegill and sunfish, and then also any type of human activity that causes water to be diverted or dry up.
We, meaning the town and the Forest Service, had to consult with U.S. Fish and Wildlife Service, and that presented challenges. U.S. Fish and Wildlife Service said, well, isn't there a different alignment for the pipeline? So this was after the pipeline had been designed, and we really said, no, there really isn't. And so we had to find a way to do the river crossings in a way that would have the least impact possible on the newly listed species. To minimize harm to the snakes, we agreed that the work on the river crossings would be, for each one would be done during a 14-day period.
The permitting process only allowed for a 14-day period to make the crossing on the East Verde River. So within that, the contractor was responsible for first diverting the channel to one side, diverting the river to one side so that he can construct on the other side. After he made his diversion, he had to excavate through a lot of rock, a large trench large enough for a sleeve that the water line was actually going to go into afterwards, and that sleeve is actually encased with concrete. And then he had to, once he got one side done, he had to re-divert it and then do the same thing again on the other side. And then after that was done, then he had to restore the area back to its native habitat, basically, with rocks and debris, just like it would have had with a natural river crossing. All that had to be done within a 14-day period, and the contractor was actually successful in completing that in a 10-day period.
Contractor on Penstock Phase 1, a company called T&T, they did the crossing at third crossing, and they did a fine job on it. And there was great concern about their ability to really fulfill all the requirements of it, and they sort of pulled out all the stops and put their best people on it and pulled it off.
Each of these 3 crossings each had their own individual problems. Crossing 3 was actually done in 2 pieces. You did half of it and then did the second half. Here at second crossing, it couldn't be done that way because there wasn't enough room. So basically what had to happen is the water had to be retained and then diverted up and over the pipeline crossing. And then on first crossing, that was all done in one shot also, and that was diverted up and over also. The water was diverted over the top because they found that having to push it to one side and then push it to the other side, you had much more reclamation to do. And we got approval from the proper sources to be able to to lift it up and over. So when we started the project, as you can see, the way it stands right now is pretty much the way it looked when we started. We filled sandbags, we made a dike across the river, put a medium diameter pipe in with the sandbags, and then used visqueen plastic on the front side of the dike and held it in place with sandbags, and then that would just funnel the water to the pipe. It allows wildlife and fish, lizards, anything you want to be able to go through that pipe because it was never full because of the volume. And it also allows no change in stream flow down below. Where that little island sticks out, that's where the dike started for the water diversion. And then we ran pipe across to about the middle of the bridge. And then we diverted the water through there so we could excavate to this side of this large rock outcropping. The riprap on both sides had to be removed, and guardrails were removed, and we excavated down here, and we went down in, and it had to be hammered. Everything was hard rock. For the installation of the carrier pipe, we just dropped it into the hole and set it, and then to put the transmission pipe through, we would put standoffs on it, which were 4 inches, and that would hold it off of the inside of the carrier pipe, and then seal it with boots on both ends and put it together and push it through, and then do a closure piece on each side. On crossing number 1, we learned how to pull the pipe in while we're pushing from the other side and do the joint connection outside of the carrier pipe. And then we push it through, and then we'd attach another piece of pipe and slide it through. And of course the standoffs were on there to prevent it from binding up inside and staying together. On crossing number 1, we ran into the problem where we had to be creative. The pump truck wasn't able to show up that morning, so we used the hose, the track mounted hose, to fill up their I think we were using 2-yard buckets, and we fill up their bucket and carry the concrete down with the hoe and place it that way until the pump truck finally got there. On this project, there was no way to be able to get trucks down in here and offload off of the truck, let alone be close enough so you don't drop the concrete too far and separate it. So the only method that could be used at this particular site was the pump truck, because that's the only way you could reach where you needed to go. We had the pump truck up on the bridge, and he was completely extended down and pumping concrete down to encase the pipe. The actual pipeline runs right up next to that, and we did have to hammer a little bit on it, and we thought we may have to take it out, but we didn't. We saved it. We thought it was a good geological feature, and we left it in place and continued up, and then replaced all the riprap both directions, and then refilled this and made the banks. And downstream, we made sure we placed rocks and had a natural dam for the pool in here that was originally here. We had a biologist, and we also had the local Forest Service construction representative. And so when we were on site, they were here monitoring our activities. And the fish habitat looks pretty good. It took some talent, both by the contractor, and it took a lot of overview from the Forest Service and the local people running the project. It was nice to have the input from them and the help, especially when you look at first crossing and the placement of the rocks, because that actually still had the old concrete from the road crossing in there. Both third crossing and second crossing both had that concrete removed when they put in the new bridges. First crossing, it was still there, so we had to go as close to that as possible, and we left it in. We had time constraints to perform the activity, and in all 3 cases, we were completed with the encasement, concrete pours, and the backfilling within the allotted time, and most of the time in 2 days prior to the window we had.
Johansson Construction did first and second crossing, and same thing. I actually felt that for both of those contractors, I thought it was kind of their finest work, that they performed best on the most challenging part of the work.
The Forest Service here and Mr. Mona were great to work with, along with the district ranger and the biologists, and the whole Tonto Forest was great to work with.
We on our end had biological monitoring requirements that had to be fulfilled.
We developed some conservation measures, and one of those conservation measures that was brought up by the Fish and Wildlife Service was to have a biological monitor on site during any time there was earthwork with heavy equipment or blasting. So each morning I would come to the construction site before they were about to use the heavy equipment and do a quick survey to make sure that I didn't see any active narrow-headed garter snakes or any snakes or frogs for that matter within the project site where they were about to do heavy equipment work. If I encountered something, I would temporarily hold it until the project work is completed and then release it back to where I found it.
If you kill a snake, it's called a take, and we anticipated that there could be a take, and as far as we know, there was never a take during any of the 3 crossings. So the 14 days was really tight, forced the contractors to work around the clock 7 days a week, at times if necessary.
Most of the crossings were done at night, and especially the excavation work, because we had to haul on the road, and we found it to be better to try to not to impact the locals.
I'd put the river crossings from an engineering standpoint at the biggest challenge, but it wasn't that the engineering was that complicated. The time element, the timing really added to the construction challenge.